Announcing for the very first time, virtual tutoring. I know I just said it, but I'll say it again. Virtual tutoring after school. If you need any help on math, okay, there's a separate Google Classroom code for it, but you can either just text me. By the way, this is not my personal number, so don't prank call me. Don't send me weird memes. Don't do that. All right. So, anyways, you can text me if you need tutoring, or email me, and we can set it up, and I can help you out. Let me know. Yeah. So let's do this warm up. Looking at this picture here, we need to name an inscribed angle. Now, is the inscribed angle in the center or on the edge? What do you think? What do you think? Is the inscribed angle the one in the middle or the one on the edge? Okay. On the edge, yes. So, everybody, inscribed is on the edge. Angle what? A is in the middle, but you always give me 3 letters. So DAC would be the inscribed angle. Angle DAC. Prescott. Get it? Anyways, what about the central angle? So does everyone know that the central angle is in the center of the circle? Right here. Angle B, right? Well, we want 3 letters to name it. So DBC, angle DBC. That works. Now, would y'all be happy if I told y'all I got y'all pizza? I got y'all pizza. Print it on your notes, you know? Right here, pizza. It looks so good. Good enough to eat, right? See, pizza. I'm delivering these pizza notes to y'all. Pizza! All right. Let's talk about pizza real quick. Y'all need to stay focused. Some of this is brand new, and I want y'all to do well on this. So here we go. All right, look right here, everybody. The front of these notes is kind of stuff you already know, but some of it is very important. So if you're holding a phone, put it away. Now look, top of the notes here. Here's the pizza I gave y'all. Yum. Aren't you glad I gave you pizza? Sorry. All right, but central angle is an angle whose vertex is the center of a circle. Write that down. Now, it says to notice a slice of a pizza is an example of a sector. We're going to talk about sectors later, but do you know how to be super cool around your friends? Is whenever you got a pizza, say, hey, can I have a sector of that pizza? And they're going to know that you mean a slice of pizza. That's cool, right? Sector. Slice, no, that's mid. Sector, that's goated. All right, well, anyways, down here, an arc. Now, if you take a pizza and you take like the edge of the crust, everyone's favorite part, right? Who likes the crust the most? Oh, wow, more than I thought. Well, I think the crust is kind of crusty. Anyways, so, but the arc is like a piece, the edge of the crust. It's an unbroken part of a circle consisting of 2 points called endpoints. Fill that in. Now it says, note, the crust of a pizza is an example of an arc. Just the edge of the crust, of course. All right, now, how do we name this arc? So if I got this crust from A on the edge to B, I would call that arc AB. Cool. Now, we have talked about this already, kind of like on our warm-up. If we have a central angle, okay, the intercepted arc is where the angle and the arc meet. Okay? So This is the most important part of the note. So is everyone listening and looking? Okay. I want you to box this. Okay. It says, note, the central angle and the intercepted arc have the same measure. This is very, very important. Look where I'm pointing right now. Whatever degrees the center is equal to the degrees of the arc that it intercepts. So if this is x degrees, right here is also going to be x degrees. Let's write that down. So here's a very easy question. If this central angle is 40 degrees, what's the arc going to be? "40 degrees. Good job, students. All right. Now, on the bottom here, we've talked about major, minor, and semicircle, right? So this should be a little review. If your pizza crust is a normal pizza crust, and it's just like a sector slice of pizza, all right? If you're like me and you eat up to here and you stop and you throw it away, just kidding. I try to eat it, you know? You don't want to waste any food. Anyways, sorry. Now, the edge from A to B, that's a minor arc because it's less than half. Minor arc is less than half, and you name it with 2 letters, from A to B. Right? Now, a major arc, how many of y'all have ever had a slice of pizza this big? Like you cut a slice and you eat the rest of it. That's a wild slice of pizza, sector of pizza. Anyways, but if you go the long way, if you have this really weird long crust, that's a major arc. It's more than half of a circle. So to name a major arc, you need 3 letters. And if I go along the edge here, it's B to B to D to A. So that's B, D, A with an arc on top. Cool. And then if you made a slice of pizza that's exactly a half of a pizza, which is still a pretty large slice of pizza, but if it's half, exactly, if it, how do I write this? Equals half. You still need 3 letters. So along the edge, B, D, E, B to D to E. That's a semicircle. Does everyone know semicircle is half? Okay. All right, so flip it over. We got new notes. Make sure you're doing this with us. We'll be done soon. All right, anyone still need this? Because we're flipping it over. Yes. Here we go. All right. Cool. Backside. This is where we're going to apply what we just learned, that the center equals the arc. Center equals the arc, okay? Now this at the top says the arc addition postulate. You might remember from Unit 1 that we've done segment addition postulate, we've done angle addition postulate. Anytime we have an addition postulate, it's the same concept. The part plus the part equals the whole. That's true forever in anything you do. You add up your little parts, you get the whole thing. It kind of makes sense, right? So let's write that somewhere. Okay, the arc addition postulate. The arc formed by the adjacent arcs is the sum of the 2 arcs. So the way I like to say it is part plus the part equals the whole thing. If I can write, here we go. Part plus part equals whole. That's what I see in this picture here. It says AD, which is this whole thing, equals AB, this part, plus BD, this part. Okay, so this is a representation of part plus part equals whole. Cool? Why am I telling you this? Well, we're going to do these examples below, and I'm going to show you how it works, but you got to stay locked in so you can understand this. It doesn't lend itself automatically, okay? So is everyone good with this so far? Here we go. Example right here. We need to find each measure. Now, didn't I just say the center equals the outside arc? So look, this central angle is 40. What is LM on the outside going to equal? 40. Okay, so let's write that on the outside. If the center is 40, the outside is 40. Isn't that very, very easy? Okay, what about if the central angle is 25? What's MN going to be? Arc MN is also going to be 25, right? So that stuff is like pretty straightforward. Don't fall asleep. All right, but here's the problem. Don't we have some missing arcs here, missing angles? I don't know what this big chunk is, or this big chunk, or this little piece, right? So here's what you got to do. So everyone hear me. You have to figure out the missing angles in the center first, okay? Now, you might remember, check me out. When you see an X, those opposite angles are equal. We call them vertical angles. Do y'all remember vertical angles? No? Okay. Let me reteach this real quick. If you see an X, the opposite angles are vertical angles, and they're equal. So where do I see an X here? So MJ and KN, doesn't that make an X? So if this is 25 degrees, the vertical angle, KPJ, right here, is going to be 25 degrees. Anytime you see an X, the opposite angles are matching. So let's go ahead and put a little 25 here. And if the central angle is 25, what's KJ out here going to be? 25. That's easy, right? No big deal. All right, now here's the part that takes a little bit of thinking. How do I figure out this big chunk here? Right, like I'm missing this big piece, but you should be able to figure it out. And let me show you how. Ready? Isn't KN a diameter? Straight across. K to N all the way across goes through the center. It's a straight line. How many degrees is a straight line? 180 degrees, right? So a straight line is 180. What do I do with this 25 to figure out the other piece? Not divide. Subtract, okay? I take the 180 straight line, subtract the 25, and that'll give me the other piece, okay? So again, I'm looking for angle JPN, 180, straight line, take away 25, and if I do the math, I get 155 is going to be right here. Again, do you see these two have to add up to 180 because they make a straight line? So if this is 155, the arc out here is what? Good. You're next. Yeah, you're next. I'm asking you easy questions. What is this going to be right here? What you see is happening here that I've been saying over and over. It's equal. So what's going to go right here? What? If this number is literally this number, if this number, what is this number going to be? Say it. What's going to go right here? Because they match. That's what I've been saying. I've been saying it over and over and over. You're listening, right? You don't got headphones in your ears, do you? Oh, then you just got to lock in, all right? So check it out, 155. Last one. How do I figure out this piece right here? Any ideas? Now this piece does not have an X. Like this goes all the way across, but this one doesn't, right? Like LP does not keep going. Okay? So it's not 155 here. But check it out. There's a few ways to do this. We have a straight line here. Right? 180. Can I take away these two from 180 to figure out this? Or how many degrees are in a whole circle? How much is a whole circle, you know? Like when I do this, whoa, 360, right? Okay, whole circle is a 360. So if you know these other four, can't you subtract these four from 360 to find the missing one. You gotta think, problem solving skills here. So let's go ahead and add the 4 we know and subtract it from the whole 360. All right. So 40 plus 25 plus 155 plus 25. So those 4 angles I know are 245. I take that away from 360, and I get 115. And like we just talked about, 115 on the middle is going to be 115 on the edge, right? Okay. Hopefully that wasn't too hard. You're going to have to be able to do that for sure. Now, the next part is not too bad. JL. I want you to follow on the edge from J to L. J to L has 2 pieces, 25 and 115. Right? J to L has 2 pieces. What do I do with those numbers? Add them up. That's it. Does that make sense? Like at the top of your page, we said part plus part equals whole, right? So from J to L, I'm adding 25 plus 115 is what? 140. Now, LJN. You're going to have to follow L to J to N. Follow the edge. L to J to N. How many pieces is LJN? LJN has 3 pieces. So you have to add the parts to get the whole, right? So let's add up LJN. It's 115 plus 25 plus 155. And I get 295. Last one, LN. LN, if I go along the edge, LN, I add up the 2 pieces, 40 plus 25 is what? What do you think? 65 is good. Okay. Do you see how this works? The center matches the arc on the outside. Find the missing ones. Part plus part equals whole. Okay. Now, does anyone still need this? Because we're going to do the last little half and then we'll be done. Good? Okay, here we go. The next one, TQ. Do you need it? Okay, TQ. Now, same thing. So maybe y'all can help me again. So, why don't you help me out? If this is 120, what goes on the outside? Okay. And if this is 80 on the outside, and then 60. Okay. So, again, the central angle matches the outside arc. So write these down. Easy peasy, lemon squeezy. Kind of cheesy. Now we have one missing angle. So I want you to remember a straight line is how many degrees? 180. So T through R is a straight line, right? So if that's 80 on the left, can't I figure out that missing space, right? 180, take away 80, 180 minus 80 is going to be 100. So 100 degrees goes here, and on the outside, 100 degrees goes here. Let's do the math. Ready? You ready? So TQ, is TQ a minor arc, a major arc, or a semicircle? What do y'all think? What do you think? TQ, minor, major, semi. Major would be more than 180, more than half. So 120 is less than 180 and less than half. right? T to Q. But that's less than 180, right? And it's not halfway, it's minor arc. So let's write minor arc. And what's the measure of TQ? Well, it's on the outside, it's 120. Cool, easy. Next one, QRT. So if you follow Q to R all the way to T, do you see QRT has 3 parts? Is that major or minor, by the way? It's more than half. It's major arc. By the way, if it has 3 letters, it's either a major arc or a semicircle. So this is major. Hey, make sure you're doing this, not that. So major arc, QRT, we're going to add the 3 parts here. 60 plus 100 plus 80 is 240. Okay, now what about TQR? If you follow T to Q to R, that is the diameter, which means it's exactly half. What do you call exactly half a circle? A semicircle. Y'all know that? Half is semi. And how many degrees is that half circle? 180. Okay, QS, 2 letters has to be, quit doing that. Quit doing that. Two letters is a minor arc. So QS is going to be minor. And from Q to S actually has 2 pieces. 60 plus 100 is 160. TS has 1 piece. It's 80 degrees. It's a minor arc because it's less than half. And it's only 2 letters. TS is 80. I need to take a picture of that so I can send it home, right? RST, if you follow R to S to T, that is exactly on the diameter. It's exactly half. Half is a semicircle, which is exactly 180 degrees. Okay. Last 2. 7 is asking for ACB, which is going the long way. ACB. Do y'all see that there's 90 right here? So that means there's 90 right here. How do I find the rest of it if the whole thing is 360 and this little piece is 90? What should I do with 360 and 90? Subtract it. 360. Take away the 90 that I know, gives me what's left over. 270 degrees. Okay, number 8, if the central angle is X, what's the outside angle going to be? X. Now, this one might seem challenging, but I want you to think about it. I know that this major arc is 4x minus 5. I know this minor arc is X, and together they make a whole circle. How many degrees is a whole circle? 360. So you can actually add those 2 pieces equal to 360. So 4x minus 5 plus x equals 360. Could you solve that equation? Yeah, you can. You got 2 x's on the same side. You're going to combine like terms. 4x plus a 1x is 5x. Bring down minus 5 equals 360. You can get rid of that loner, minus 5, by doing the opposite. You add 5 to both sides. 5x equals 365, and then you can divide by 5, and you will get x equals 365 over 5 is 73. Okay, now I'm passing out this assignment. You got a little bit of time today, but you do have tomorrow. If I were you, I would prioritize the other two assignments for Monday and Tuesday. Okay? Again, you will have time tomorrow. You got a little time today. Go with your time. Let's get it. Weren't you late? Yeah, go ahead. You can go. What is it?
Call you.
What are you calling?